Okay, so today we are again going to talk about arrays in Java. So arrays are basically, special variables. Normal variables store just one value, whereas in case of arrays, you can store more than one value in a single variable. So a normal int variable, let's say s, when I define a variable like this, so it basically means there is just one. Let's imagine this variable as a container, so this container is called s. So when we define a normal variable using the data types, so it basically means that there is a single space where I can store, since it's defined as int, I can store a single integer value in this place. So it could be any integer value, it could be 5, it could be 10, it could be any number, any integer number. In case of arrays, what happens is, instead of defining in the normal way that we define variables, we use third brackets, and we define it in this way. So let's say I just want to define the array, I do not want to initialize it with values. So I'll just define the array by writing it in this way. So we need to write this entire line to define the array. What happens is, so let's change the name of this variable to avoid any confusion. So um, let's call it a. So a is now a list of 5 elements. So it will have 5 places which can store 5 different values. So in case of a normal variable definition, a single variable holds a single value. But in case of arrays, a single variable can have more than one value. So I could store 5 different numbers, let's say 5 different integers to be specific. Let's say -1, 0, 1, 5, 52. So this is one of the advantages of using arrays. So instead of uh, being able to store just one value in one variable, I can store multiple values in a single variable. So arrays are used to store multiple values in a single variable instead of declaring separate variables for each value. So instead of defining 5 separate variables for these 5 different values, I'm just defining a single variable a in the form of an array which can store all the 5 values in this single variable. So to declare an array, we define the variable type with square brackets. So you could either do it in this way, where you are placing the third brackets right next to the name of the data type. So this is one way of declaring it, or you could do it in this way. You could either place, let's you could either place it here after the variable name, or you could do it in this way. So both these definitions are one and the same. So you could either do it in this way, where you write it just after. So let me modify that. So there are no spaces in between. So just after the um, data type, you give a third bracket, and after that you give a space and write the variable name. Or you could do it in this way. We normally do it in this way, but you could also write it in this way. So as you can see here in this example, they have used the um, latter method of defining an array. So this is how we declare an array. So we could just declare an array like this. So instead of writing this part, we could just write it. We could just declare the array. Then we could do the definition in a separate line. So we could just write it as int a. We could do could separate these. We could separate this line into two lines. Um, or we could just write it in a single line in a combined fashion. So um, just like this example here. So we have defined a string array called cars. So the name of the array is cars. Now once we have declared the array, we can insert values as follows. So we declare the array using the third brackets. So here we declare the array using the third brackets. We give a name to the array, and to insert values into the array we use the curly braces. And we since this is a string array, so we have inverted commas as we have in strings. While we do also we use inverted commas to define strings. So this is one particular value of the array, this is another value, this is another value, and this is the fourth value. So there are four different values of the which have been inserted into the cars array, which is of string type. So defining it in this way, defining arrays in this way, when you already know what values to store in the array, you do not need to follow this, or rather this approach. This is usually followed when you do not know the exact values. So this particular method is followed when you do not exactly know, when you do not know the exact values that are going to be inserted into the array. Whereas on the other hand, as in the example given in the notes, so I could also do, let's say I know the values that are going to be inserted beforehand, so I could do it like this. So int a is equal to, since this is an integer type array, so I'll not be needing the inverted commas. So let's say I am using these five values. So -1, 0, 1, 5, 52. So this is also another form of definition and initialization. So this happens in one single step. You could do it in this way, in a single step. You could also divide this into two different lines. So you could just write int a, and then you could initialize it in this way. So you either follow this or you follow this. So we usually follow the first approach. So we usually do this. So if we know the elements beforehand, if we know the elements, and or rather we could call them the values of the array. If we know the elements or the values that are going to be stored in the array beforehand, we can do it in this way. Or if we do not know the exact values that are going to be stored in the array, we will be following this approach. So I hope this is pretty simple. When we know the values beforehand, it's pretty simple. The definition and the initialization is pretty simple. You just specify the data type, use third brackets, define a name for the array, or rather choose a name for the array, have the equal to sign, and then you use curly braces, and inside the curly braces you separate each element or each value using a comma. So if it is a string, it will have inverted commas. If it is a character, it will have single inverted commas. If it is an int, it will have integer values separated by commas. So make sure you separate each element or value using a comma when you're initializing the array. So we are going to uh, talk about talk a little about the other format where you do not know what elements are going to be stored beforehand. So I have an array int a. So I'll be breaking this statement down into the various parts and what role they are playing. So this is just the basic definition. It's the same as when you are using this. So let me write it here. So when I already know the values that are going to be stored in the array. So let's, for the sake of simplicity, let's say 0, 1, 2, 3, 4. So I have 5 elements. So when I already know the values of that are going to be stored in the array, I do it in this way. This particular part is same for both the cases. So this particular part is same for both the cases. If I know the elements or the values beforehand, or if I do not know the elements beforehand, this particular part up till the equal to sign is same for both the cases. So there are two ways by which I can define arrays. In both the ways, this particular portion is same. The main difference that lies is in this part. So this part is different for when I know the values beforehand versus when I do not know the values beforehand. So when I know the values beforehand, I use curly braces and I'll write the values inside the curly braces separated by commas. So I'll separate each value with a comma. When I do not know the values beforehand, but I know how many values there are going to be. So um, you may not know what the exact values that are going to be stored in the array are, but you must know the exact number of values that are going to be stored. If you do not know the exact number of values, you will not be able to define the array, or rather declare the array. So this particular number must be known beforehand. This number corresponds to the number of elements or the array size. So this is basically, this number corresponds to the array size or the size of the array. So if the array, so 5, writing 5 here means the array can hold 5 values. Writing 10 here would mean that the array can store 10 values. Remember, this particular value can never be negative. So first point to remember is the size of the array cannot be negative. It makes sense, right? Because um, there's no point in defining an array with a negative size. So what's the no? So when we need an array, when we need to store variables, only at that time we'll be defining an array. So negative values, having negative value as a size has no point at all. So this particular value or a this will always be a number or an integer. It cannot be a fraction also. So the size of the array cannot be a fraction or decimal value. I can't have 2.5 elements, right? So that's not allowed. I can always have, you know, full elements. I cannot have a half element. So it can either be a full element or no element at all. So I cannot have something in between. So it's logically not possible. So the size of the array cannot be negative. That's the first point. The size of the array cannot be a fraction or a decimal value. So you need to remember these 2 points when defining the size of the array. This particular value is the size of the array, which corresponds to the number of elements the array can hold. Coming to this new keyword here, so we have previously also used the new keyword to define objects of a class. So the new keyword basically does the same job uh, here as well. So when defining objects of a class, we use the new keyword so that memory is allocated to the object. So here also the new keyword does the same job. It allocates, you know, different five consecutive spaces in memory. So what the new keyword does is, let's say this is memory, or rather, let me draw it a little bit bigger. So let's say I have memory. Memory has a lot of cells, so it's not actually represented internally in this way, but for the sake of representation we are going to use this visual um, representation. So let's say this is my memory. My memory has 1 2 3 4 5 1 2 3 4 20 cells. So the size of my memory, so this is memory of size 20. So there are 20 cells, so counting from here and going in this fashion, so I have 1 2 3 4 5, then 6 7. So let me write it down. So this is 1 2 3 4 5. Next we have 6 7 8. So we're counting in this fashion. It's not important, but uh, when we are defining single dimensional arrays, so this is nothing but the array that we have defined. So this is a single dimensional array, which means when I've defined the array, let's say so I was talking about the new keyword. What the new keyword does is it will block. Let's say this particular portion of the memory was available, so it will block this portion, these 5 cells in the memory. Since I've defined my array to be of size 5, so the size of my array is 5. In memory, what happens is, due to the new keyword that I have used, 5 contiguous memory cells will be blocked for my array, or rather allocated to the array that I have defined. The point that you must remember is these cells are contiguous, which means they lie one after the other. It's not, done haphazardly, where one memory space is allocated here and the other memory space is allocated here, then here. It's not done in that haphazard manner. In case of arrays, it's always allocated, contiguous cells are always allocated, which means adjacent cells are used to store the elements of an array. So when I'm defining an array of size 5 as I have defined above, or if I do it in this way also, what happens is uh, 0 is stored here, or rather the first element is stored here. So talking with respect to this format of definition, 0 gets stored here, 1 is stored here, 2, 3 and 4, and in such a way. So if let's say the array has more than 5 values, so since I do not have any more cells here, so there are no more cells here, so the next particular value will be stored. Let's say I have an array which has 6 elements, so the next number is 5, so this new value will be stored here. So uh, basically what you need to remember is in memory, arrays are stored, single dimensional arrays wherein I have just one single dimension are stored in contiguous cells. So the first element will be stored here, the second element here, the third element here, the fourth element here, fifth one here, the sixth one here, and so on. Okay, so this is the job of the new keyword. The new keyword allocates, since I've defined it as defined an array of size 5, it blocks 5 cells. So 1 2 3 4 5, so these 5 cells will be blocked for this particular array called A. Okay, so that's how it's internally done in memory. So my point is to explain the job of the new keyword. So the new keyword basically what it does is it allocates memory. In case of arrays, continuous memory locations or contiguous memory locations. So the word is contiguous memory locations. It's very important to remember this particular term. They may ask you during Viva or during exams. So always remember arrays are allocated memory in a contiguous fashion. So if the array is of size 5, 5 contiguous memory locations will be blocked with the array name. So let's get back here. So here we have the variable called cars of string type, which is an array. So cars basically is, so how many elements does car have? It has 1 2 3 and 4, so there are 4 memory locations. So 1 2 3 and 4, so this is the cars array. So the first element that is stored in cars is Volvo, BMW, Ford and Mazda. BMW, which is the second element, Ford and Mazda. So all these 4 values are brands of different cars. So Volvo is a different brand, BMW is a different brand, and so are the other two. So this particular statement that has been given, string cars is equal to Volvo, BMW, Ford, Mazda. So this particular line corresponds to this, something like this in memory. So that's an example of a string array. We could also have integer arrays as I used in my previous demonstration. So I hope the process of creating arrays is clear. So I could either use this method, or I could use where when I do not know the name or the value of values that are going to be stored, I can use this particular format. New string. Always remember, I must always know the size of the array. So even if you do not know the size of the array, you must take a guess at what would the size of the array be like. So here I know there are 4 separate values, so I'll have 4 as the size of the array. This field can never be blank. So cannot be blank, must be an integer value, cannot be negative. Okay, so just remember these few points. It cannot be blank, it cannot be negative, it cannot be a fraction. So it cannot be a fraction, it can only be an integer value. And you must know it beforehand. Even if you do not know what exact what exact values are being stored, you must know the number of values that are going to be stored beforehand. So let's say there's a question which says define an array to store the given values. So the given values are, let's say, so the first question I have integer values -1, -92, 553, 37, 6. For the second question I have string values, um, fruits, vegetables. They may or may not use inverted commas when they're giving you the question nuts. Um, Cereals. And for the third one, let's say we have decimal values. So 0.25, 56.7, 32.3, 71.0. So how are you going to define arrays to store these given values? So point to be noted is that I already have, or rather I already know the values beforehand. So it's pretty simple here on out. So the answers for the first one would be, since so take a look at the arrays, take a look at the values rather. All the values are homogeneous in a particular question. The values are homogeneous. What do you mean by homogeneous? It means that it has the same type of values. So all of them are integers. There is no mixture of values. So you cannot have one integer, one string, and one float type value and store them in the same array. Okay, we will be talking about limitations of arrays as we go further. So, the point to be noted, or rather the feature that you could that you should know, realize at first glance, is that all the values that have been given to you in a particular question, they are of the same data type. There are no mixed values. All of them are homogeneous values. So in the first case, in case of question number A, we have all integer values. So I'll be defining an integer array. I could give it any name. Let's call it A. Since I already know the number of values beforehand, I'll just define the array using the given values. And that's the answer to question number A. In case of question number B, again, if you take a look at the values, all of them are of data type string. So there are no, there's no mixing of data types here. So all the values are string type, and this is also homogeneous. So I'll define a string array like this. Let's call it S, and I'll just put in the values. So fruits separated by a comma, vegetables. So I separate each value using a comma, nuts and cereals. That's the answer to question number B. And for question number C, again, we see that all the values given in the question are of decimal type or floating type. So we have float, let's call it F, is equal to 0 0.25, 56.7, 32.3, and 71.0. So that's the answer to question number C. Now let's say I have one more question, D, where I have these values. So if they give you a question like this, so they give you a question like this and they ask you to define an array to store these given values. The answer to this question would be, since the given data is not homogeneous, so keyword to remember, homogeneous, it cannot be stored in an array. So if they give you a question like this and they ask you to define an array using these given values, your answer would be, since the given data is not homogeneous, it cannot be stored in an array. So now let's talk about the limitations of arrays. So we have already come across two limitations. So limitations slash disadvantages of using arrays. So the first limitation is, as we have already seen, the size of the array must be known beforehand. So you must know the size of the array before defining the array. So the size of the array must be known beforehand. That was the first limitation that we came across. Second limitation is related to the data that is being stored in the array. So the data to be stored in an array must be homogeneous, which means of same data type. So these are the two limitations that we have come across as of now. The first one is the size of the array must be known beforehand, and the second limitation is that the data to be stored in an array must be homogeneous, which means all the values in a single array must be of the same data type. Let's also take a look at the advantages of using arrays. So before we move on with arrays, let's take a look at the advantages. What are the advantages? Why should we use arrays? So I've already talked about the size limit in disadvantages. So there's a limit. We can only store, so size limit. So we have talked about knowing the size beforehand. So that's basically, there's a limitation on the size of the array. Arrays of fixed size. You have to, whenever you define an array, so the size of the array gets fixed. You cannot change it afterwards. Dynamically you cannot change it afterwards. While running the program, you cannot change the size of the array. You could do it, you could open the program and then edit the size of the array. That's a different story. But while running the array, let's say the uh, customer or the user to whom you have sold your program, so while he's running the program, he cannot dynamically change the size of the array. Let's say he initially is working with an array of size 5. He cannot, while running the program, you know um, directly change the size of the array to 10. Let's say he is in need of 10 elements instead of 5. So my point is, the size of the array once defined, it's fixed. It cannot be changed while running the program. So that is one of the limitations. So the size of the array must be known beforehand, which is equivalent to uh, this particular point. The size of the array is fixed at the time of definition. It cannot be changed. It cannot be changed while the program is being used. So remember the keyword static that we talked about. So once a variable is defined as static, its value doesn't change. So the size of the array is somewhat similar to the static function, or the function of the static keyword. So the size of an array is static, which means it is fixed, and it's not dynamic, which means that it cannot be changed while the program is running. So this is again the first and the third limitations are more or less interrelated. So the size of the array must be known beforehand, which also means the size of the array is fixed at the time of the definition. It cannot be changed while the program is being used. Second limitation is the data to be stored in an array must be homogeneous, which means it has to be of the same, all the values has to be of the same data type. So these are the three limitations. And talking about advantages, um, code optimization. So it makes the code optimized. We can retrieve or sort the data efficiently. So think about having 100 different variables for 100 different values compared to having one variable that can store 100 values. So you just need to remember one name for 100 different values, and you can just use the index number. So we'll talk about indexing later on as we move forward, but you just need to remember one variable name for 100 different values, and you can use some sort of way to directly access any of those 100 values, instead of having to remember 100 different variable names for the 100 different values. So that is what is meant by code optimization. So now let's talk about the advantages. So advantages of arrays. So the first advantage that we are talking about is code optimization, which means 100 different. So 100 is just a small number. It could be more than 100. So for simplicity, I'm saying 100 different numbers. So normally in real life scenarios, the number is quite huge. It's not just limited to 100, it could be any number. So 100 different values stored in 100 separate variables. So 100 different values stored in 100 different variables versus 100 different values stored in one single variable. Fascinating, isn't it? So 100 different values stored in 100 separate variables. There are various problems with it. You have to remember 100 separate variable names. Let's say there's a problem with a particular variable. You would have to search all the 100 variables, and finding out the problem variable is difficult in the first case. Whereas in the second case, I just have one single variable that has 100 different values. I can just, I just have to remember one single variable name. And also, while searching for a problem value, let's say a single value has a problem, I could just, very easily run a search operation on the um, values, and I can easily get the location of the problem value, and I can easily modify it. Talking about the search or operations similar to it. So searching elements in an array is much more easier than searching, values in separate variables. Because in case of arrays, all the values are stored in contiguous memory locations or contiguous cells. So if I know the first address, I can just add 1 to it and go to the next location. Again, add 1 to it and move on to the next location. So internally searching is faster. And whereas in case of 100 different values, they could be stored anywhere in memory. So finding them in the background. So I'm talking about the background task, as in how it's implemented in the hardware. So while searching for 100 different values stored in 100 separate variables, time taken is much more than for 100 different values stored in a single array variable. Okay, so that is what is meant by code optimization. So the using arrays, the code is much more optimized in case of searching and sorting. So we'll come across searching and sorting later on. but those functions are much more faster in case of arrays compared to using separate variables for separate values. And the second advantage is random access. As I told you, if you know the location, you can directly grab hold of a value stored in an array. So before we talk about random access, let's talk about how, since we are storing the multiple values in a single variable, how to, identify the different values in that variable. So let's talk about an array of size 5. So this is an array 1, 2, 3, 4, 5. So, and this has 0, 1, 2, 3, 4. So these are the values stored in the array. The array is called A. Now, think about it. Previously, when we used to store different values in separate variables, we could just use that variable, a particular variable name, to find a particular value. So things were separate, neatly separated. But here in this case, I have just one single variable, but I have five different values. So A could mean any one of these values, right? So how do we differentiate, or rather, how do we, pinpoint the exact value that we are looking for? That is done using something called. So to exactly pinpoint a value in an array, we have something called an index. So since we are using one single variable, we use something called an index to pinpoint the location, the exact location of a value. Let's say we would like to find the location of, we would like to find the location of the value 2 in the array. So how do we refer? Let's say I want to use I want to use this value. Uh, let's say I want to use this particular value in an operation. So I'm writing a program. I've defined an array in this way. I want to use this particular value in some sort of operation that I'm doing in my program. So how do I access this value? It's pretty simple. We use the variable name followed by third brackets, and we use the corresponding index of that value. So a of 2 will refer to the value 2. Similarly, a of uh, so let's take a different example. This will be a bit confusing since the let's take different values rather. Since the index numbers and the values are same, it might be a bit confusing. So let us consider different values. So I have the array here. So let's say 72, 56, 47, 91, 200. So let's consider these values. Now, let's say I want to access the value 47, which I need in some sort of calculation that I am doing. So how will I access 47 here in the array? There's something called an index number. Every value in an array has a unique index number. So the first element of the array has an index number of 0. The second element of the array has an index number of 1. The third element of the array has an index number of 2, and so on. So the indexing of the elements. So this is called indexing. So the first location is marked as 0. So a of 0 will correspond to the value 72 in our program. So when an array is defined, an index is also set. The index starts from 0, the zeroth, so the first location in the array or the first value in the array is represented by the index 0. The second location or the second value in the array is represented by the index 1, and so on. It increases by 1 up at every step. So it starts with 0 and increases by 1 at every step. This is known as index. So these particular values, this is called an index number or index, the array index. So let's say I want the value stored at the fifth location of the array. So it will be a of 4. So I would have to write a of 4, which corresponds to the value stored at the fifth location, which is 200. Again, here there are 2 points to remember in case of array indexing. So points to remember: in case of array indices, so the plural of index is indices. So these are the points to remember. The index of the first element, so we call the values in an array elements. So the first element, which means the first value or the first location. So the index of the first element or the first value or the first location, all three of them mean the same thing. So this is the first element or the first location of the array or the first value that is being stored in the array. So the index of this will always start at 0. That is the first point to remember. And the ith location in an array is given by rather should I should write it in this way. So the value at the ith location should be the value at the ith location in the array is given by a of I minus 1. which means, as in the above example, the fifth location value is given by or corresponds to a of 4. It's pretty simple. See, take a look. This is the fifth location, so this is the fifth location, but take a look at the index number. It's 1 minus the number of the location. So this is the fifth pocket or the fifth location or the fifth element, but the index number is 1 less than the position of the element. So since it is starting from 0, it's basically because it is starting from 0, so it's 1 less than the position of the element. First position is 0. First position, which means the position number 1 is 0, which is 1 less than 1. Position of the second element is 1, which is 2 minus 1 is 1. So in that way. Remember the 2 points. The index of the first element will always start with 0. The value at the ith location in the array is given by a of I minus 1. So the value at the fifth location of the array is given by a of 5 minus 1, which is equal to a of 4. These are two important points that you need to remember when working with arrays. So accessing values in an array is done in this way. If you know the exact index of the value, you can directly use this form of notation. So you could simply use the way, rather let me write the generic way of the syntax. So array name followed by the index number. So that's how you access a particular value inside an array. You write the array name, you use the third brackets, and you specify the index number of the particular value, provided you know the index number of that value. Even so, we could search for the value in an array. We'll be talking about searching later on, but for the time being, let's say you know the index number of the value that is being stored that you want to find. So you just directly use the array name and the index number, and you get the value, corresponding value that is stored at that particular index. Okay. So just like here, take a look at this example. So they're using the index position or the index number to directly. Here they are changing. So cars 0 corresponds to this particular value. So they're changing Volvo to Opel. So now when they print cars 0, it will print Opel instead of Volvo. So that's how you access elements inside an array. So this is an important point to remember. So array indexes start with 0, which means 0 is the first element, 1 is the second element, and so on. So the 0th index corresponds to the first element, the 1th index corresponds to the second element, and so on. Remember, array indexes always start with 0. So That's how we define arrays, and that's how we access the different values stored inside an array. Now, there's one last thing that I like to cover before we end today's class. That is a function called length. So, length is a function, or rather, length is a property of an array. It's wrong to call it a function because it does not have function brackets. So, there are two separate definitions, or rather two things which is pretty, people get confused a lot. One is the length function, and the other one is the length property. So one is a function, so this is a function, whereas this is a property. This is a property of array, this is a function, this is a string function. So students usually get confused between these two. This particular thing is a property of arrays, which means it defines a feature of it, a particular feature of any array, and this particular thing is a function which works upon strings. So this, what it does is, it will give you the length of a string or the number of characters, which is equivalent to the number of characters in the string. So the length function is a string function which gives you the number of characters in a string, whereas the length property, this particular property, when used with arrays, returns the length of the array. So for example, I have an array int, sorry, so this would be, so let's say I have an array, আওয়াজটা একটু কম করো. So let's say I have an array int array a that has some values, and I want to find the length of this array. So to find the length of this array, or to find the length of any given array, I could simply use the length property of an array. So I define another variable size which corresponds to the size of the array. I could just use the length property in this way. So now when I do sopln size, my output would be the number of variables in the array. So there are 5 variables, so my output will be 5. So the length property is a very important property. We'll be using it when we work with arrays in further classes. So when we do not know the exact length of an array, we can use very conveniently use the length property of an array, and we can call it in this way. Use the array name followed by the dot operator and then the length property. We store it in a variable and we get the size of the array. So the output of this is 5. So I hope the function of the length property of an array is clear. Do not confuse it with the length function, the string function length, which returns the number of characters in the string. Length is a property, it is not a function. Length is a property of arrays. Using that, we can find the size of an array. So that's all for today's class.